Hi, this is Mr. Bissonette with another episode of Math in the Classroom. Today, we're going to work on simplifying composite functions. Previously, what we did was we were given a value for the composite functions, we plugged that value in, and then from one equation it went into the next equation, and we solved it for a given value. This time it's going to be a little bit different because we're not going to be given the value, we're just going to be given the two equations and then we simplify it from there. So today's learning target is I can simplify composite functions. Alright, so let's start off with if we have f of g of x. Just so you know, some other notation for the same thing might look like this. F of g of x. So some write it like that, some write it like that. Doesn't really matter, whichever one you prefer, just so you know that both are saying the same thing. Okay, so we're going to go with, let's simplify f of g of x, and let's say f of x equals x squared plus 2x, and g of x equals x plus 1. Okay, first thing, g of x, that function is going to go inside our f of x. So what we're going to do is we're going to take this whole part of g of x, the g of x function, and then we're going to plug that in to our f of x right into the x there. So here we go. We'd have f of g of x is going to equal the function x plus 1 squared plus 2 times the function x plus 1. Okay, there's the first step. Now, once we have this, we're going to simplify it. How do we know what to do when we're simplifying? We're simply following our PEMDAS, just like we do all the other times. Okay, so we're going to start with our exponents. Parentheses would be simplifying what's inside the parentheses. We can't simplify anything there inside the parentheses, so then we go to our exponents. So we would have f of g of x is going to equal this x plus 1 times x plus 1 plus our 2 times x plus 1. Okay. When we're here, now we have to multiply two binomials, so we'll have that x times that x times the 1, and then we'll move to our 1 times x and 1 times 1. So we will have f of g of x equals x times x, which is going to be x squared, x times 1, which is going to be x, 1 times 7 is 7, 1 times 8 is 8, 1 times x is x, back to 1 times x again, which is x, and 1 times 1, which is 1. Okay, so we'll take a quick little pause right here. Now, this is one of those questions that my math students always ask, Mr. B, when are we going to use this in the real world? And again, get mad at me for this, but a little bit of a personal opinion / backed with some of the history of mathematics and all of that. There's a lot of times when math won't be used in the real world. Outside of the classroom, I have never done this. And even a lot of the top math professions, they're not doing necessarily this kind of math on the daily. They're measuring something, they're putting it into a computer program, they're running it through the computer program, and they're getting the answer that way. That all being said, some of these skills will help you when you get into calculus, being able to simplify expressions, to be able to take the derivative of something easier. Like, that is true. But I think the better way of thinking about math is not necessarily when will we use it in the real world, but think of it as like a set of rules. This is the rules of math, PEMDAS. And you learn the rules, you follow the rules, and you can play the game. So I know it's kind of a little different way of thinking about it, but it's one of those ones that I always encourage the students. Don't think about it as, when am I going to use this in the real world? Think about it like playing a game. learn the rules, then you can play the game. Okay, so we did our exponents. Now we're going to simplify. And once we simplify, then we move on to our multiplying and dividing. So f of g of x, we have x squared, x plus x is going to be 2x plus 1 plus our 2 times our x plus 1. The other really important thing that I tell my students when they start getting up to that upper level is find a way of staying organized. It's a learned skill. You have to practice it. Be patient with yourself. Take the time, write it out, go step by step. When the problems get a lot longer, it will make a big difference. We actually made a mistake in math class. Today I made a mistake when we're going through one of these long problems. And because we had every step by step, we were able to look back and be like, oh, there's where we made our mistake, we fixed it, and we were able to go on. If the math is all over the place, it's hard to track down those mistakes. All right, here we go again. So now we're going to multiply or distribute that 2, so 2 times our x and 2 times our 1. So we're going to have f of g of x equals x squared plus 2x plus 1 plus 2x plus 2. 2 times x is our 2x, 2 times 1 is our 2. We're going to simplify. We have 2x, we have plus 1 and plus 2. So we're going to get f of g of x is going to equal x squared. 2x plus 2x is going to be 4x. 1 plus 2 is going to be 3. Okay, this would be our simplified expression. So f of g of x would equal x squared plus 4x plus 3. I then had a student, after we went through it, they go, Mr. B, is that going to be equal to if we just plugged the value into here and solved it and then plugged it into there? Or are these essentially equal to that process? Well, let's take a look at it. Let's grab a value. Let's say x equals 2. So f of g of x, so we would do our g of x first, so we'd have 2 plus 1, which is 3. Plug the 3 in. 3 squared is 9 plus 2 times 3, which is going to be 6, and 9 plus 6 is going to be 15. So if we use 2, if we did f of g of 2, we would get 15. Let's double check that one more time. 2 plus 1 is 3, plug our 3 in. 3 squared is 9, 6, 9, and 6 is going to be our 15. Now we bring that right down to here. We would have f of g of 2, and we plug it in. So we'd have 2 squared plus 4 times 2 plus 3. 2 squared is going to be 4. 4 times 2 is going to be 8. 4, 8 is 12. And 12 and 3 is going to be 15. So f of g of 2 does equal 15 when we simplify it. And you can see it doesn't matter which form, which way we go. Again, when you get later on in math, it might be easier to be able to combine those functions and then simplify it. Again, some really mathy stuff. I really enjoy it. I have a lot of fun. I really like the algebra side of it. But it is pretty mathy. But that is how we simplify our composite functions. Thank you.